Last class we have discussed about our energy coefficient alpha. Okay, so we have derived that equation. Okay, so this is our general equation for your energy coefficient alpha. Okay, and then we have taken one example of rectangular channel. Okay, and then we have discussed how to solve alpha for rectangular channel. Okay, and then we have discussed about the velocity, how to calculate this velocity, that is your average velocity. The last class we have discussed all these things. Okay, so see here in this chapter we have numericals related to your how to find out alpha, your energy coefficient. Then to find out alpha we need to find out v. Okay, then only we can determine your energy coefficient. And another one term is your momentum coefficient, is your momentum coefficient beta. Okay, so the derivation is very much similar to alpha. Okay, for momentum coefficient, for momentum coefficient beta, the derivation is similar to your alpha. But here we know what is momentum. Momentum is mass into velocity. Okay, momentum is mass into velocity. Okay? Momentum is mass into velocity. So again we are going to consider small elementary area. We have already discussed what is small elementary area. When we derive alpha energy coefficient or momentum coefficient, we have to consider a small elementary area. Okay, small elementary area. Now what we do, we are going to find out the momentum in that particular small area. Okay, that is mass into velocity. Mass into velocity. So for mass, we have already derived that equation when we discuss about coefficient, energy coefficient. We have already know the equation for mass. Okay, this is your weight and this is your mass. Mass is this. So we are using the same equation for beta also. Okay, specific weight divided by acceleration due to gravity multiplied by area, that is del A, as we are considering the small elementary area, multiplied by the velocity v, that is small v. Okay, small v is the velocity of water or velocity of flow inside the small elementary area. Okay, so here you can see as this is your mass. Okay, as we are considering momentum, so it's mass into this velocity. Okay, so this is specific weight divided by acceleration due to gravity multiplied by area, that is del A, area of the small elementary area, and then we have to multiply it by velocity. Okay, and this v is nothing but your velocity. Okay, so this is your mass, this is your mass, and this is your velocity. Okay, here we have one mistake here, only v square. Okay, to do the correction, this will be your okay. This is your typing mistake, I think. Here, this is wrong. Okay, this is specific weight divided by acceleration due to gravity multiplied by elementary area, that is del A, del area multiplied by velocity. Okay, this is mass. Then again, if you consider momentum, we have to multiply the mass into velocity. So there will be again one velocity. Okay, so here it's written v square. This will be only single v. Okay, then after multiplying this two, then only you can say this is v square. Okay, so this is correct. This is correct. So this is you strike out this equation and you write this equation. Specific weight divided by acceleration due to gravity multiplied by small elementary area multiplied by velocity. So this whole gives you mass. Okay? This whole gives you mass, and then you again multiply it by velocity to get momentum. Mass into velocity. Okay. So again, this momentum, what we have calculated, this is only for the small elementary area. Okay. If this is your small elementary area, whatever momentum we have calculated, this momentum is only for this particular area. Okay, so for total momentum, again we have to take integration or summation. Okay, so these things very much similar to your alpha derivation. Okay, this is your total momentum. Okay, now as our velocity is not constant, we have to multiply it by a coefficient, that is your beta. Okay, so when you use that coefficient for momentum equation, then it calls beta. Okay, when you use that coefficient for energy equation, then it is called alpha. So alpha is for energy equation and beta is for momentum equation. The purpose is same. Why we are multiplying that coefficient? That purpose is same. Okay, so then again we have calculated total momentum, and then this is our corrected momentum for the whole cross section. Okay, then we equate both the equation like what we did for alpha. Okay, then we equate both the equation, and then we find out the beta value. Simple mathematics. Okay, so definitely this specific weight by gravity and specific weight by gravity will be cancelled out. Okay, so in place of discharge, okay, they have written area into velocity. We all know discharge is equal to area into velocity. So that's why beta multiplied by area into velocity. In place of discharge, they have written area into velocity. Then we have velocity here. Okay, so this is summation del A v square. Okay, then you find out the beta. Okay, and in place of summation, we replace the summation by integration. So similarly, okay, similarly, for example, we have taken rectangular channel because rectangular channel is very simple to understand. Okay, this is your rectangular channel. Y naught is the depth, okay, and width of the channel. B is the width of the channel. So here now, if we consider a small elementary area here, so your del A will be B into dy. The width of the channel is B, and for the small elementary area, your depth is dy. Okay, so we've calculated dA, then total area for the whole cross section for the rectangular channel is B multiplied by y naught, as we have considered y naught as the total depth of flow. Okay, now you substitute in this equation. So 1 by area, in place of area, we have substitute b into y naught. Okay. Then small v by capital V whole square. Then del A again, we have substitute b into dy. Okay. And definitely that integration, for integration, the limit from 0 to y naught. We have already discussed about this thing. Okay. How the limit changes. So it will be from 0 to y naught, and we are integrated with respect to y. We are integrated. We are integrating with respect to y. Okay. So to calculate alpha and beta, we have to first calculate this average velocity, that is your capital V. Okay. So whenever there is a numerical related to alpha and beta, it is asked or not, you have to first calculate your average velocity. Then only you can find out your alpha and beta. Okay. Or if it is given, then it is okay. Okay. If it is not given, then you have to calculate alpha and beta. Okay. So what we do, we will solve some numericals related to alpha, beta, and your average velocity. Okay. So I ask you to pen and paper. Okay. You just be ready with a pen and paper. We solve some numericals. Unless and until you solve, you are not going to understand. Okay. So as it is very difficult, online process. Okay. Okay. So this is the first example, and we are going to solve this example. Okay. Okay. Are you ready with your pen and paper? Which is channel section is rectangular. Okay. Then rectangular channel of width is B. The rectangular channel which is B. Okay. And depth y naught. Depth is y naught. And depth is y naught. Okay. After that, what it says, see, if you remember the alpha equation, if you remember the alpha equation, it is integration 0 to y naught small v by capital V whole cube dA by capital area. Okay. Okay. So to find out this, what we required, we need small v, we need capital V. Okay. So for small v, we have that expression. Okay. We have that expression. It's given small v is equal to k multiplied by root over y, where k is a constant, where k is a constant, and y is nothing but your depth of flow. Okay. So now we proceed to the solution. Okay. So we have already discussed to find out alpha and beta. First, we have to calculate V. Okay. So this is the equation for V. Okay. So in place of small v, we have substitute that equation. In place of small v, we have substitute this equation, that is k multiplied by root over y. Okay, so in place of root over y, we have written half. We have written to the power half. Okay, it's the same thing. Okay, you can write k into root over y, or you can write k into y to the power half. So dy. Okay, 1 by y naught, 0 to y naught. That is the limit. We have already discussed the limit will be from 0 to depth of flow. So as here, the depth of flow is given 0 to y naught. Okay, y naught is the maximum depth. Okay? So now you integrate. Okay, so we are integrating with respect to y. So k will be a constant term, so it will come out. Okay, that is why k by y naught. K by y naught. Then integration of y to the power half plus 1 divided by half plus 1. Okay, okay. So what will be y to the power 3 by 2 divided by 3 by 2. Okay, so if you bring this out, so it will be reverse 2 by 3. Okay, understood now? Integration of y to the power half will be your, if you integrate y to the power half, it is not, this is nothing but y half plus 1. Okay, divided by half plus 1. Okay, so what will happen, this y to the power 3 by 2 divided by 3 by 2. So this you can also write 2 by 3. As you bring out here, 2 will go up. Okay, multiplied by y to the power 3 by 2. Okay, y to the power 3 by 2. So that is why here k is constant, it comes out. So this is your constant term. Then we have integrated y to the power half. So in place of y to the power half, we can write 2 by 3, y to the power 3 by 2, and the limit is from 0 to y naught. Okay, now what we have to do, now we have to substitute the limit. So k by y naught is the constant. Okay, then 3 by 2, 2 by 3 is also constant now. Okay, then we have to substitute the limit. Those things you have already studied in mathematics. Okay, so why not? First, we will substitute, it will be y is equal to y naught. Okay, y naught to the power 3 by 2 minus. Then we are going to substitute in place of y the next limit, that is 0. 0 to the power 3 by 2. Okay, So similarly, am I audible?
Yes, sir. Now you're audible.
Okay, okay, fine. Yeah, okay.
Yes,
Network
sir.
issue. Okay. Yes, yes.
Sir.
Yes, Tasi. So here is already given rectangular channel. You can directly use the equation for rectangular channel. Okay, that we have already derived. Okay, or you have v, we substitute k root over y. So in place of root over y, we have written y to the power half. Okay, so dy will be there. So this equation is only for rectangular channel. Okay, so don't be confused, as we have already derived this equation, so we have directly used. Okay, as the question, that is the channel is given rectangular. Okay, then what you have to do, we have to integrate. Okay, as k is a constant, it's already given in the question that where k is a constant, so when we integrate it will come out. Okay, so k by y naught, then you integrate y to the power half. When you integrate y to the power half, when you integrate y to the power half, so it will be y to the power 1 by 2 plus 1. Okay, divided by 1 by 2 plus 1. So half plus 1, it is 3 by 2. So you can write this thing, y to the power 3 by 2 divided by 3 by 2. Okay, this is simple integration. Okay, so this thing, you again you can write 2 by 3. If you take it out, it will be revised 2 by 3 multiplied by y to the power 3 by 2. Okay, so here the steps are missing. They have directly given 2 by 3 y to the power 3 by 2. Okay, then we have to substitute the limit. Okay, then we have to substitute the limit. So v is equal to k by y naught multiplied by 2 by 3. Then we have to first substitute the higher limit, that is your y naught. Okay, y naught is your maximum limit. So we are always deducting from higher minus the lower one. Okay, so in place of y, we are going to substitute y naught. Okay, so y naught to the power 3 by 2. Okay, minus 0 to the power 3 by 2. Okay, so this will gives you k divided by y naught multiplied by 2 by 3 multiplied by, as this will be 0 to the power 3 by 2, it's 0. So what will be remaining, y naught to the power 3 by 2. Okay, so again if you simplify 2 by 3 k. Okay, k will be there. Then we have y naught 3 by 2, as we have divided by y naught, so it will be minus 1. Okay, I think this thing you know. Okay, when you have y to the power 3 by 2 divided by y naught, you can write y naught 3 by 2 minus 1. Okay, so it will be again 2 by 3 multiplied by k multiplied by 1 by 2. So half, y naught to the power half. Okay, understood? So your ultimate expression will be 2 by
Yes.
3
Yes,
into
sir.
y naught to the power half. Okay, So here you see, so this is your final expression for your average velocity. Okay, dA by, okay. So this is your general equation. Okay, so for again small v, in place of small v, we need to substitute a root over y. That is given in the question. Okay, in capital V, we need to substitute this equation that we have derived. Okay, and for del A, again for rectangular channel, it's b into y. Okay, and area is, sorry, for del A, it's b into del y. Okay, as it is a rectangular channel, it's b into del y, and for area, b into y naught. Okay, so try to solve. Okay, alpha value, it's 1.35. Try to solve. If you have any problems, then we can discuss here. Okay, okay, so you try to find out the value of alpha. Any doubts? So, okay. So Similarly, you find out beta also. Doubts regarding this? I will give you in that WhatsApp group. Okay, the same equation. So all are requested to give their enrollment ID in the chat box. Okay, for attendance. Okay, so we will continue in the next class. Okay, you try to solve this numerical where that velocity we have already calculated and values I have already given. Okay, you try once to solve it at home. Okay, or if you have any doubts, then we will discuss in the next class. Okay, thank you. You have not given your enrollment ID in the chat box. Okay, kindly give your enrollment ID for attendance.